Good morning, students. Welcome to Deeksha Online. Today, we will discuss some questions in P block elements, that is group 15 to group 18. Example 1. In which of the following compounds which has maximum SS linkages? The options are Na2S2O3 sodium thiosulfate, Na2S2O4, Na2S4O6 and Na2S6O6. So if you see the formula, the number of sulfur atom is also going to be important to have SS linkages. So the structures of the compound, if you take in option D, that is Na2S6O6, the structure will be, if I take Na2S6O6, so this is giving rise to 2Na plus and S6O6 2 minus. So here sulfur has two double bonds and one single bond with O minus. In between two such groups there are four sulfur atoms. This is the structure of S6O6. So in case of Na2S4O6 also, instead of having 4, there are 2 sulfur atoms. So this is Na2S6O6, there are 4 sulfur atoms. So number of SS linkages will be 1, 2, 3, 4 and 5. So there are 5 SS linkages. So this is the compound with highest number of SS linkage. So answer should be D. Example 2. Which of the following pairs of metals liberate hydrogen from dilute nitric acid? So metals react with nitric acid at different concentration of nitric acid in different way. So the metals react with concentrated nitric acid giving NO2 as a gas byproduct along with the nitrate, and metals also react with dilute nitric acid giving N2O or NO as a byproduct. But metals which are amphoteric like zinc and magnesium, when they react with very dilute nitric acid, they liberate hydrogen as the product. So if we take among the given option, the amphoteric metals, that is zinc and magnesium, will be the one which will give hydrogen with nitric acid, which can further combine with nitric acid to form ammonia. Then ammonia react with nitric acid again to form ammonium nitrate as a byproduct. So zinc and magnesium, when they react with dilute nitric acid, they do liberate hydrogen, but the hydrogen liberated will again reduce by HNO3 to NH3, and NH3 converts into respective ammonium nitrate by the reaction with nitric acid. So answer should be zinc and magnesium, because copper will give NO or N2O. Iron will give again NO or N2O dilute nitric acid. It doesn't give hydrogen. With concentrated nitric acid, iron, copper, everything will give NO2. So option should be magnesium and zinc. Example 3. Which of the following reaction shows the existence of Cl2O6 as ClO2 minus ClO4 plus in solid state? So Cl2O6 compound can exist as actually this is gaseous phase. If you take solid phase, exist as ClO2 plus and ClO4 minus. So ClO4 minus, sorry, ClO2 minus ClO4 plus in the solid state. That's the question which is being asked. So ClO4 plus should exist and ClO2 minus should exist. So if you take the combination, the positive ion, this is ClO2 minus, this is ClO4 plus. So negative ion should combine with positive ion should combine with negative ion. So when I react with ClO2, Cl2O6 with HF, so F should combine with ClO4 minus. So I should get FClO4 minus FClO4, and H plus should combine with ClO2 minus HCl. This should be the combination which tells us the existence of ClO2 minus and ClO4 plus in the reaction medium. So the option should be FClO4 and HClO2. It should be A, not B. It should be A. Example 4. In which the following redox reaction, X cannot be. So we have KMnO4 sulfuric acid medium giving potassium sulfate, manganese sulfate giving nascent hydrogen. So nascent oxygen. So KMnO4 is an oxidizing agent in acid medium. The nascent oxygen is taken by X to convert into oxidized product Y. So indirectly it is asking that which of the following species cannot be further oxidized. So if you take the options, CO can be oxidized to CO can be oxidized to CO2, possible. So if I go for the other two options, 1 second, I'll take the next slide. CO plus nascent oxygen can become CO2. The other two options, if I have SO3 2 minus plus nascent oxygen can become SO4 2 minus. And oxalate ion, all of us know oxalate ion on oxidation can become carbon dioxide. So if I take the oxidation number, in carbon oxalate ion is plus 3 and CO2 is plus 4. Whereas if I take SO4 2 minus with oxygen, there cannot be any reaction, because in sulfate ion already sulfur is in the highest oxidation state. So this is the answer which cannot be oxidized. So X cannot be SO4 2 minus. So answer should be B. Example 5. When oxalic acid reacts with concentrated sulfuric acid, two gases are produced. So potassium hydroxide absorbs one of the gas, and the product formed during this absorption and the gas absorbed respectively are. Okay, so we'll go to the solution. So oxalic acid H2C2O4, when I treat with sulfuric acid, concentrated sulfuric acid, all of us know concentrated sulfuric acid can act as a dehydrating agent. So H2O is taken out from this, and it results the formation of carbon monoxide and carbon dioxide. So if I write the first structure, C double bond O OH, C double bond O OH. So this water is taken effectively, and one becomes CO2, other becomes CO. CO and CO2, CO is neutral, CO2 is acidic. So when I react this with KOH, it absorbs CO2. So KOH plus CO2 can become K2CO3 plus H2O. So in this particular example, H2C2O4 oxalic acid react with concentrated sulfuric acid, gives CO and CO2, and CO2 is absorbed by KOH, and the product formed is potassium carbonate. So answer should be CO2 and K2CO3, option D. Example 6. Example 6, we have a sequence where we identify X, Y and Z. So we'll take the solution, then we'll come back to options. So we know H3PO4 is given orthophosphoric acid. This on heating up to a temperature of 250 degrees Celsius, this converts into pyrophosphoric acid, that is H4P2O7. This pyrophosphoric acid on heating to 600 degrees Celsius becomes HPO3 metaphosphoric acid. Then H3PO4, even if I directly heat up to 600 degree also, it gives the same product. Then finally, when we go for very strong heating, it gets completely dehydrated to form P2O5, which can dimerize to become P4O10. So X should be H4P2O7, Y should be HPO3, and Z should be P4O10. According to the given options, option A should be the right answer. Example 7. Which of the following statement is correct? Acidic nature of oxyacids of phosphorus depends on number of POH bonds. So acidic nature of oxyacids of phosphorus. So the monoacidic, diacidic, that depends upon the number of POH bond, but the acidic nature or acidic strength depends mainly on the oxidation number of the phosphorus atom. So higher the oxidation number of phosphorus atom, more will be the acidic strength. Okay, so this is not exactly right, appears to be right, but not exactly right. So N2O3 exists and N2O5 does not exist. So here N2O3 exists, N2O5 can also exist. So N2O3 exists, N2O5 will also exist. Decomposition of N2O5 we have studied in equilibrium all. So N2O5 can also exist. So this is not a very correct statements. The highest oxidation state of nitrogen and phosphorus is +5 in the corresponding oxyacids. So nitrogen HNO3, if you take, oxidation number of nitrogen is +5, and H3PO4 also you take, it's going to be +5. So +5 is the oxidation state of nitrogen as well as phosphorus in the corresponding oxyacid, that is HNO3 and H3PO4. So this is a correct statement. PF3 is more covalent than NF3. So NF3, the difference in the electronegativity is less. The bonds are relatively less polar, remain more covalent in nature. Phosphorus and fluorine, the electronegative difference is more. It is more ionic than NF3 but less covalent than NF3. So option D is also wrong. So answer should be C. So answer should be C. Example 8. Which of the following statement is correct with respect to N2O? So So N2O, what is the structure? So we know N2O, so two nitrogen double bonded to each other and bonded to oxygen. So this will have two lone pairs. Oxygen also will have two lone pairs. The formal charge here is +1, here formal charge is -1. So this is the structure of N2O. It is very much linear, but because nitrogen oxygen is there, it is non-symmetrical or unsymmetrical. And also we can write resonating structures. This is one structure. I can write two more structure. So this electron pair can go here. This electron pair can go here. So I can get nitrogen triple bond, nitrogen single bond O with three lone pairs on oxygen. That is minus. This will be plus. So this is one more structure for compound. It can show resonance. Can show resonance. So we will see the options, what it says. This is the structure of N2O. If I go back to the question, so it is a linear and symmetrical molecule, which is not correct. It's linear but not symmetrical. So option A is wrong. It is linear and unsymmetrical molecule is correct. It exhibits resonance, correct. And it has small value of dipole moment. See, oxygen is having a different pulling nature. Nitrogen is less electronegative. So it will have, even though it is linear, the dipole bond moments are not getting completely cancelled out. So it will have a small dipole moment. So option B, C, D are the correct statements. A is the wrong statement. So answer should be B, C, D. Going to example 9. Which of the following is the correct order of thermal stability of hydrates of group 15? So NH3, PS3, ASS3 is given. We should know that the thermal stability of hydrates decreases as we go down the group. Okay. So order should be NH3 should be more stable, then PH3, then ASH3. So this is the order. Thermal stability decreases down the group. So option should be ammonia, PH3 and ASH3. If I see the option, it's going to be A. NH3 greater than PH3 greater than ASH3. We'll go to the example 10. Formation of pH4. Formation of pH4 is difficult when compared to NH4 plus. So we'll see how NH4 plus and pH4 plus can be formed. See, ammonia is a Lewis base. Ammonia is a Lewis base. When I add any acid H plus, the lone pair of nitrogen is given to H, forming a coordinate bond. So it forms NH4 tetrahedral species. So the formation of NH4 involve transfer of the lone pair to electron deficient proton. Same way if I want to do PH3. PH3 also have a lone pair H plus. So it can form PH4 plus same way. So the question is saying that difficulty in formation of PH4 plus like NH4 plus. NH4 plus easily formed. The basic strength of phosphine is much less than basic strength of ammonia. Why is that? So the availability of lone pair becomes the criteria, as we know that as we go down the group in the group 15, the involvement of pure orbital is increasing in bonding. So phosphorus predominantly uses pure p orbital for bonding, and hybridization is going to be decreased. So as we go down, hybrid orbitals are not involved, pure p orbitals are involved. As a result, the lone pair of phosphorus is not available for bonding. I can't say it is not available at all. It is difficult to get, so it is not a correct statement. Lone pair of phosphorus resides in almost pure p orbital. Not correct. So lone pair is actually the configuration you take. It is 3s2 3p3. 3s2 is the lone pair, 3p is 1 electrons in p orbital. So lone pair of electrons resides in pure s orbital, which is much dragged into the nucleus because s orbital has higher penetration power towards the nucleus. As a result, as much firmly held by the nucleus, it is not easily available for bonding. So I would say D is the correct answer. Then the A non-availability is not correct. Available but difficult to take. So lone pair is residing in s orbital, which is more penetrated towards nucleus. Example 11. Which of the following statement is true? So NH3 is less soluble than pH3 in water. NH3 is less soluble than pH3 in water. So that is difficult to accept because ammonia forms hydrogen bonding with water. Ammonia is going to be very highly soluble in water compared to even pH3, where pH3 cannot form hydrogen bonding with water. So A is wrong. NH3 is a stronger base and a stronger reducing agent than pH3. So definitely NH3 is a stronger base, but reducing agent, reducing capacity is more for pH3. pH3 acts as a better reducing agent. It can give away hydride ion more easily than NH3. So NH3 definitely acts as a strong base, but because of the lone pair is easily available for reaction, but reducing capacity is more for pH3. pH bond can break to give hydride ion. NH3 is having higher boiling point but lower melting point than pH3. So NH3 is having a higher boiling point for sure and also higher melting point because ammonia is going to have hydrogen bonding among themselves. So intermolecular hydrogen bonding will elevate the boiling point and also the melting point is going to be higher than pH3. So NH3 has a higher boiling point and higher melting point than pH3. So this is also a wrong statement. In case of D, if I take pH3 is a stronger reducing agent than ammonia and has a lower critical temperature than NH3. NH3 intermolecular forces are strong. NH3 can be quite easily liquefied compared to pH3. As a result, the critical temperature of pH3 is less than that of NH3. So option D is the correct statement. Option D is the answer. Example 12. Compounds A and B treated with dilute HCl separately. Two compounds treated with dilute HCl separately. The gases liberated are Y and Z respectively. So the Y gas turns acidified dichromate paper to green and Z turns lead acetate paper to black. The salts A and B are. This is a question based on salt analysis, or you can take in the P block. So in salt analysis, we do the first group acid radicals. So we know that the gas which can be oxidized, which can turn acidified dichromate paper to green, that means it is a sulfur dioxide gas, sulfur dioxide. So in place of dichromate, H plus, it becomes SO3 and this will turn into Cr3 plus, which is green in color. So SO2 can be oxidized to SO3. So sulfides will give SO2 gas on treatment with dilute HCl. So when we treat the salt with dilute HCl, if I get sulfur dioxide gas, it will have sulfide radical, and if it is having carbon dioxide being liberated, the carbonate or bicarbonate will be present in the salt. Same way the second one is given, the gas is converting lead acetate to a black color. So lead acetate will be CH3 COO twice Pb. So if I want to convert this to black, I have to get sulfide S2 minus or H2S. H2S should be there. Then it becomes PbS, which is black. So salt A is giving SO2 gas, that is, and salt B is giving, this is Y and this is Z. So A should be a sulfite, B should be a sulfide. So A should be a sulfite and B should be sulfide. So if you see the options, so Na2SO3 and Na2S, option B. Na2SO3 on treatment with dilute HCl give SO2, and Na2S on treatment with HCl will give H2S. SO2 will turn acidified dichromate paper green and H2S will turn lead acetate paper to black. This is the answer, that is B. Example 13. Which of the following pairs produce the same gas during the given reaction? So we'll take one by one. First one, calcium nitride in dilute HCl, NH4NO2 on heating. So if I take calcium nitride, Ca3N2, any nitride will have N3 minus ion. By add HCl or even water, when you heat it, you get calcium chloride here along with NH3. So ammonia gas is liberated. Same way, if I take NH4NO2, it will give nitrogen gas on heating. So decomposition of ammonium nitride will give nitrogen and H2O. So the gases are not same. One is giving ammonia, other is giving nitrogen. So option A is not correct. Option B, ammonium dichromate and ammonium nitrate. Ammonium nitrate and ammonium dichromate. So NH4 twice Cr2O7. This is a very important reaction. On thermal decomposition, this will give nitrogen as one of the product. Same way, NH4NO2 on thermal decomposition also give nitrogen as one of the product. So both gases will give, both the salts will give nitrogen gas. This is one of the answer. Ammonium nitrate on heating and magnesium nitrate on heating. See, ammonium nitrate on heating will give N2O. Ammonium nitrate on heating will give N2O, and magnesium nitrate on heating will give NO2. So NO2 and N2O are not same. So the third option is also wrong. In case of fourth one, ammonium chloride on heating will give ammonia and HCl, and even NaNO3 with zinc and NaOH will give ammonia. So both are able to give ammonia gas. So this option is also right. So NH4Cl on heating, NaNO3 with zinc and NaOH on heating will give ammonia. So option should be B and D. B and D. Example 14. Which of the following statement is incorrect? So it is bismuth 3 compounds and Sb3 compounds. So all of us know about inert pair effect. In case of inert pair effect in P block, as we go down the group, the stability of the lower oxidation state increases, especially towards the end of the group. The last element will have higher stability for lower oxidation state. So bismuth 3 compounds are more stable than Sb3 compounds. So bismuth 3 compounds definitely more stable compared to Sb3 compounds. Bismuth plus 3 is more stable than Sb plus 3. So this is a correct statement. That means not an answer for the given question. Second statement, Bi3 compounds are less stable compared to other compounds of bismuth in the other oxidation state. So only oxidation state possible is Bi5 plus Bi3 plus. So Bi3 plus is obviously more stable than Bi5 plus. So this is a wrong statement and answer for the given question. And B3 plus act as good reducing agent. If the ion has to act as a good reducing agent, it should be easily oxidizable. So among B3 plus and B5 plus, if I take oxidation of B3 plus, so Be3 plus, B3 plus becoming bismuth, sorry, beryllium alla, bismuth 5 plus. So bismuth 3 plus and bismuth 5 plus. So this is more stable. This is less stable. So since it is less stable, the oxidation is not easier. If oxidation is not easier, it is a bad reducing agent. So option C is also a wrong statement and the correct answer for the given question. So B and C are right now. Bismuth chloride solution on dilution forms a precipitate of bismuth hypochlorite. So this also not a correct statement, and bismuth chloride solution on dilution is not exactly forming hypochlorite. So D is also wrong statement and a correct answer for the question. So answer should be B, C and D. So due to inert pair effect, always Bi3 plus is more stable than Bi5 plus. Similarly, in carbon group, Pb2 plus is more stable than Pb4 plus. Example 15. Which of the following is not a characteristic feature of interhalogen compounds? So if I take the options, they are more reactive than halogens. They are quite unstable, but none of them are explosives. They are covalent in nature. They have low boiling and melting point. So not a characteristic feature. Okay. So they are more reactive than halogens because of more polarity of the bond, difference in electronegativity. Normal halogens are nothing but same halogen atoms are bonded. Electronegativity difference is 0, but still they are going to be reactive. They can break the bond and take part in the reaction. But interhalogen compounds having different halogens, definitely they are much more reactive than halogen. So that is a characteristic feature which is not an answer. They are quite unstable, but none of them are explosives. Because of their high reactivity, they are quite explosive in nature. So because of that, the reactivity is very high, they can be even explosive. So option 2 is not defining the characteristics of interhalogen compound. They can be even explosives. They are covalent in nature compared to halogen. Halogens are perfect covalent molecule, but because of electronegativity difference is there in the atoms, they are having predominantly even ionic character. They are covalent compounds, but ionic nature is much higher, and they have low they are covalent in nature, covalent molecules, but there is ionic character in the molecules. They have low boiling and melting points. So compared to inorganic compounds which are salts, the complete ionic compounds, if I take, these are also having relatively lower boiling and melting points because the covalent nature is there for the bonding in case of interhalogen compounds. So except B, all other are characteristic feature of interhalogen compounds. So option should be B. Example 16. Which of the following order of acidic strength is not correct? Incorrect. So if I take the acidic strength of order of these, so HCl, HBr, HI. So we'll take in the next slide itself. HCl, HBr, HI. So all of us know the acidic strength is going to increase as we go from HCl to HI. HI is a strong acid and HF is the weak acid. So in that given order it is reverse, so that is A is incorrect order. And in case of oxyacids of chlorine, second option, so HClO4 is most acidic compared to HClO3, compared to HClO2, compared to HClO. As the oxidation number of the central atom increases, the acidic strength increases. So this is correct order what is given in the given question. Then third order is HF, then water, then ammonia. So HF is more acidic, water is relatively neutral, ammonia is basic compared to water. So acidic strength decreases from HF to ammonia, which is correct. Among perhalic acids, HClO4, HBrO4 and HiO4, HClO4 is the strongest acid. The order should be HClO4, then HBrO4, then it should be HiO4. The given option is actually opposite to that. So option A and D are incorrect, option B and C are correct. So in the given option, answer is A and D. This is incorrect, this is incorrect. These two are correct orders. Example 17. Which of the following xenon compound is isostructural with ICl2 minus? ICl2 minus. So first we'll find out the hybridization. Iodine, the number of valence electrons are 7 plus 2 monovalent atoms and the charge minus 1, so you have to add 1 by 2. So it is 10 by 2, which is equal to 5, then it is sp3d hybridization. If it is sp3d hybridization, the number of bond pairs are 2 because 2 chlorine atoms are there. So bond pair equals 2, lone pair equals 3. So the shape would be linear. ICl2 minus is linear. So now the given question is, which of the following compound of xenon is also linear? So if I take XeF4, XeF6, XeF8 and XeF2. So linear means it has to be XeF2. If I take XeF2 also, because 2 atoms are only there, XeF4 is square planar, XeF4 is square planar, XeF6 is distorted octahedron, and XeF2 is linear. So if I take this, 8 is the number of atoms in number of electrons in xenon plus 2 monovalent atoms, no charge by 2, it is 10 by 2. So it is 5, means this also sp3d. So sp3d with 2 bond pair and 3 lone pairs, it has to be linear like ICl2 minus. So it is isostructural with ICl2. So answer should be XeF2. Answer C. Example 18. On heating with concentrated NaOH and an inert atmosphere of CO2, white phosphorus gives a gas. Which of the following statement is incorrect? Incorrect. So if you take the reaction P plus NaOH, it is a disproportionation reaction, gives PH3 as the gaseous compound. Other one is NaH2PO2. So PH3 is the gaseous compound which is produced. Compared the properties of PH3, we have to take a look with the options. So options given. So it is highly poisonous and has a smell of rotten fish. So it is highly poisonous and has a smell of rotten fish. So PH3 is a poisonous gas. This is a correct statement. The solution in any solution that decomposes in presence of light. The solution in water of pH3 can decompose in presence of light. That is also right statement. But wrong statement, it is more basic than ammonia. So already we discussed this. pH3 is less basic than ammonia because lone pair is quite involved in the pure s orbital, which is much penetrated towards the nucleus. As a result, it is less basic than ammonia. This is the wrong statement and they are asking for incorrect. So this is the answer for the given question. Bond angle will be less than ammonia. It is also possibly right answer. It is a right answer because in pH3 pure p orbitals are involved for bonding rather than sp3 hybrid orbitals. So because of pure p orbitals are involved, they are oriented along perpendicular direction to each other. Bond angle will be close to 90 degrees. But in case of NH3, bond angle is around 104 degrees, 107 degrees. Okay, so bond angle is less than ammonia is a correct statement. So wrong statement is only C, and that is the answer for the given question. Example 18. Which of the following is not correctly matched? So conceptual again. Decon process, manufacture of Cl2 and Cu2Cl2 is as a catalyst, correct one. Haber's process, manufacturing ammonia, iron catalyst with the molybdenum promoter is correct. Contact process, manufacture of H2SO4, platinum or vanadium pentoxide is used as a catalyst. And Ostwald process, manufacture of HNO3, but the catalyst is wrong. Catalyst is platinum rhodium gauze, or even I can use V2O5. Manganese cannot be used as a catalyst. So option D is the answer. Question number 19. Which of the following statement is correct with respect to sulfuric acid? It has a high boiling point and high viscosity. Sulfuric acid is much viscous. Concentrated sulfuric acid solution, if you see, it is much viscous liquid and has a very high boiling point. That is a correct statement. P pi D pi bonding is observed between sulfur and oxygen, which is also very correct. So structure of sulfuric acid, if you take sulfur, Lewis structure is this. So in Lewis structure, the sulfur oxygen bond is taken as coordinate bond, but actually it is P pi D pi, double bonds are involved. This is P pi D pi bond because sulfur has vacant d orbital, so it can extend its valency beyond 4, and it is using its d orbital for pi bond formation with oxygen p orbital. So there are P pi D pi bonding in sulfuric acid between sulfur and oxygen. So option B is also correct. There are two types of bond lengths in bivalent anion. So in bivalent anion is sulfate ion. the structure, if I take S double bond O, single bond O minus, single bond O minus. So it appears as if there are two types of bond, one is single bond, one is double bond, but actually it is a resonating molecule, resonating ion. And we can write 6 structures and all of them are equally contributing, and actually in sulfate ion all bond lengths are exactly equal and all bonds are exactly identical. So that is a wrong statement again. This is correct, this is correct, this is wrong. Sulfur has same hybridization as boron in diborane. Diborane, if I take the structure of diborane, B2H6, so B, H, H, then B, H, H. So there is a banana bond between two boron atoms. So boron is practically bonded to 4 hydrogen atoms. So it is like sp3 hybridization. Sulfur in sulfate ion also it is going to be tetrahedral in structure, and this is also going to be sp3 hybridized. So both are having sp3 hybridization. So it is also correct statement. So answer should be A, B and D. Question number 20. Select the incorrect statement with respect to following reaction. So if I take the reaction XeF6 SbF5 giving cation and anion. So we'll see what is the product. The reaction goes like this: XeF6 plus SbF5 gives rise to XeF5 plus and SbF6 minus. So this is actually acting as a F minus donor. So the cationic part is XeF5 plus and anionic part is SbF6 minus. If you see the options now, XeF6 acts as a fluoride donor, which is correct. Hybridization of central atom of cationic part is sp3d2. So what is the central cationic part? XeF5 plus. So number of valence electrons in xenon will be 8. Monovalent atoms are 5. Positive charge, are to subtract 1, divided by 2. So 13 minus 1, 12 by 2 becomes 6, means the hybridization is sp3d2. So it is a correct statement. So this is correct, this is correct. Anionic part is isostructural with PCl6 minus. So Sb also comes in the same group. So PCl6 minus or SbF6 minus will be isostructural, which is also right. Both cation and anion have identical shape. So cation is XeF5 plus and SbF6 minus. So both are definitely sp3d2 hybridization, but shape is different because this one lone pair is there here, 0 lone pair is there. This is octahedron and this will be square pyramidal. So shapes are different, hybridization are same. So D is a wrong statement. So answer should be incorrect. They are asking, it should be D. A, B, C are correct. So D is the answer. Question number 21. Which of the following shapes are not possible for XeFn molecule? So what are the possibilities of XeFn? We know N can be any number. So we have XeF2, we have XeF4 and we have XeF6. XeF2 is linear, XeF4 is seesaw, and XeF6 is distorted octahedron. Okay, so SF4 is seesaw, XeF4 is not seesaw, it is square planar. So because hybridization is sp3d2 with two lone pairs and perfectly octahedral structure, octahedral geometry, two lone pairs makes it square planar shape. XeF6 will have sp3d3 hybridization with one lone pair, that is why distorted octahedron. So these three structures are possible. So we'll see what are the given options. So it is linear possible, square planar possible, trigonal planar not possible, distorted octahedron is possible. Answer should be C. Example 22. Which of the following is a correct order of solubility of noble gases in water? So noble gases are known to have very least solubility because of their inertness. Among them, if you take the mass becomes more, the solubility will be relatively more. So neon will have the least solubility because it is very small, very inert, and doesn't have solubility at normal temperature. Van der Waals forces will matter. So van der Waals forces are going to be very least for neon. So the order should be, as you go down the group in the noble gases, the solubility increases. So neon is least and xenon should be maximum. So option should be, in this case, if I take, it should be D. Conceptual question 23. For an interhalogen compound XX-3, the correct statement is. So we'll see what exactly is interhalogen compound. So in interhalogen compounds, normally if I take the examples, ClF3, BrF3. So Cl is in the first halogen is in positive oxidation number. The second halogen is in negative oxidation number, cation and anion. So the less electronegative atom becomes cationic part and the more electronegative atom becomes anionic part. So fluorine, being the atom cannot be showing positive oxidation number, so fluorine cannot be the first halogen in any interhalogen compound. So fluorine can take only the anionic part. So the first halogen should be less electronegative and second halogen should be more electronegative. So if I go for the options, what is given, let us see. Size of X. So X is the first halogen atom and X dash is the second halogen atom. So size of X greater than size of X dash. So X dash is fluorine, then X can be chlorine, bromine or iodine. So size of chlorine, bromine, iodine should be greater compared to fluorine. Same way, if X dash becomes chlorine, X will be bromine or iodine. As a result, the first statement is correct. They are asking for correct statements. Okay, this is correct. Electronegativity of X is greater than that of X dash. So X dash should be always more electronegative halogen compared to X. So this is a wrong statement. X cannot be fluorine. That is a right statement. All the above are correct will be wrong. Answer should be A and C. It should be A and C. Both are correct. Question number 24. XeF6 on complete hydrolysis gives. So if I take XeF6, hydrolyze. So all F can be replaced by OH. That is a complete hydrolysis. If I do it, There are 6 OH on one single atom, so it will lose water immediately, loses 3 molecules of water, finally forming XeO3. That's the product with complete hydrolysis of XeF6. So option C, XeO3. Example 25. Which of the following reaction do not produce ammonia? So if I take the first one, ammonium salts with KOH. Ammonium salts with KOH produces ammonia. So this will give ammonia gas. N2 plus 3H2 Haber's process will obviously give ammonia. This is also correct. Nitride Mg3N2. Nitride will have N3 minus. We take a proton. This will also give ammonia. But ammonium dichromate on heating gives only N2, not ammonia. So D is the answer for the given question. Answer is D. So these are the questions what I thought I will discuss with you in the group 15 revision class. Thank you.